Hello everyone, we are here to secure our communications. What that means? Our organizations need to provide security for data that is stored on our machines as well as moving across network links. Well, to get started, we're not just going to start sending data around. Let's start first by making sure our data is the correct data. For example, on my desktop I have this folder titled Important. And in this Important folder, I've got these 6 files. Now how do I make sure that these 6 files that have data inside them have not been maliciously altered or changed since I last used them? Well, that's called hashing. It's part of data integrity. What I can do is open up another program, for example, this one, Quick Hash, and I can go to that directory and I can select the directory of important where all those files are in. And if I go into important and click select, this program is going to hash all of those files. And due to the exact bits of data in each file, we will get a specific hash value that correlates to that file. But what would it look like if one of those files had been altered? How could I check that? For example, maybe financial records or employee passwords. I can go to an individual file and select it in this hash program. And how about we do employee passwords? And it will give me a hash output. Now what I can do is I can go into this file of employee passwords and I'll change it by 1 character. To change it by 1 character in employee passwords, how about Dragon 0 becomes Dragon 00 with 2 zeros. What I'll do is save the file employee passwords. We're going to go back into that hashing program and we're going to take a look at how this hash is about to change. Before it was 6.5 in the beginning, 4.6.3 at the end. Let's go to that employee passwords file one more time. And take a look at this. It is completely different. And to compare it, I'm going to paste in here what I expected the hash to be, what it should have been if it didn't change. And the program says this does not match the previous hash. If you compare those two, they are completely different just by adding on an extra 0. So this is data integrity using hashing. What we're going to look at now next is the idea of encryption. What we want to verify here is that when we move our files from one place to another, it's nice to know that they haven't been modified using integrity and hashing, but it's also nice to know that they haven't been intercepted and viewed. So we need to encrypt these files. Now to do this, I'm going to use an open source program known as 7-zip. And with 7-zip, I have it looking at that directory marked as important, and I will take a couple files. How about employee passwords and employee records? I'll take these two, I'm going to right click on them, and I'm going to put them in an archive with 7-zip. And this is going to give me some options. The options first is to name the file. And I'm just going to name this file as secure.7zip. And for the password, which is going to be a symmetric encryption password, I'm going to use super secure. And this is going to encrypt these files inside of this new file known as secure.7z. And in order for people to decrypt and view these files, they'll have to have the encryption password of super secure. Since it's the same password used to encrypt and decrypt, that's known as symmetric encryption. I'll click OK, and we're going to encrypt those 2 files. First one's done, and second one's done. So I've got this new file, secure.7z. And in order to gain access to it and view the confidential data inside of it, I'd have to right-click, go to 7-zip, and I'd say extract to secure. From there, I get my password pop up in order to decrypt the contents, and that would be the password again of super secure. So you can see it, and I'll click OK. From there, it's going to open up a new directory right here. It's decrypted those files, and now those files are right here. If I wanted to now, I can verify these files have not been altered in transit, and that would be by using my hashing program for data integrity. So cryptography here is going to provide you data integrity, origin authentication, making sure a message is not a forgery and actually comes who it said it came from. Data confidentiality, which is our encryption and making sure that if data is intercepted, it can't be deciphered. And also non-repudiation, where it guarantees that the sender cannot refute the validity of their message. They are the one who originally sent it and they have signed off on it.